Hi guys, welcome to lesson 9-1. This one's all about writing and graphing inequalities in two variables, and it'll start up on page 151. Hey, I hope you like this background. I was kind of looking for some new backgrounds and I found this one. It reminds me of an old couch my grandma used to have. It was really green and kind of bumpy. Anyway, so we have a couple goals here. We want to be able to write linear inequalities in two variables. Remember, as soon as you see inequality, you're thinking not an equation. So it's not just a certain line. There's going to be a shaded area that goes along with this. And then we want to be able to read and interpret the graph of the solutions of a linear inequality in two variables. So not just read it, but we want to be able to understand what it means in the context of the situation. So we've got these two peeps here, Axel and Anisa. I swear, I think Springboard hires a guy just to sit around and come up with names for their math book stories. This is hilarious. Axel and Anisa pay for and share memory storage at a remote internet site. Their plan allows them to upload 250 terabytes or less of data each month. X is going to stand for the number of terabytes Axel uploads in a month, and Y is going to represent the number of terabytes Anisa uploads in a month. So number one says, look at the data for 4 months below and determine if Axel and Anisa stayed within the limits of their plan. So their limits are 250 terabytes. So this one looks good. They stayed in the limits there. This would be 235, so that looks okay. This one would be at 250, so yep, 250 or less it said, so that's okay. And this one's going to give us 280 something, so that is a no. They went beyond the plan. Those kids. Okay, so I'm going to reiterate, in case it's not your habit already, that you should definitely pause this and do these things by yourself before you just watch and copy. So if we're supposed to write an inequality that models the plan's restriction on uploading, if X is Axel and Y is Anisa, then the amount that each of them upload together has to be less than or equal to 250, which is their limit. So for number 3, if Axel uploads 100 terabytes, write an inequality that shows how many terabytes Anisa can upload. Well, if he already uploaded 100 and their limit is 250, then she could do 150 or less. 150 or less. On the other hand, if Anisa uploads 75 terabytes, to write an inequality that shows how many terabytes Axel can upload for their 250 limit, Axel is X, so he could upload up to 175 terabytes and still be within the limit. So hopefully all that is making sense to you so far. All right, so now we get into the nuts and bolts of this. It's not enough to just know how to graph an inequality. You need to understand why you'd bother graphing it and what the graph means. What's the meaning of all this stuff? So this summarizes it here by saying the graph below represents the possible values for the number of terabytes that Axel and Anisa can upload. An ordered pair, X, Y, represents the number of terabytes that Axel and Anisa upload. For example, the coordinates 100 and 75 mean that Axel uploaded 100 terabytes and Anisa uploaded 75 terabytes of data. So all of this, well, we're going to get to that in a second, but this shaded area in here in the blue part represents all of the different combinations of uploads that they'd be allowed to do. Remember, the x-axis is Axel's uploads in terabytes, and these are Anisa's uploads. It always helps to have labels on a graph, or you've got a fairly useless graph that you don't have any information about. So, a couple tips. Some equations and inequalities are graphed on the coordinate plane but contain only one variable. For example, x equals 1 or y is less than 3. I hope. I want you to pause this and think about what kind of lines each of those would make. And then see if you decided that this one crosses the x-axis, so it would be vertical. And that this one crosses the y-axis, so it would be horizontal. Man, I hope you're getting that stuff. That's something I want you to own. And then we've got a couple other forms here. These are both equations and inequalities that are in two variables that would be graphed on the coordinate plane too. Hopefully we wouldn't really try doing either of these until we got them in a form we understood, like perhaps slope-intercept form, but they would work. And then here we have a description of what a linear inequality is. It's in this form. Ax plus by is greater than c, or greater than equal to c, or less than c, or less than or equal to c. A, b, and c are constants, and a and b are not both 0. Because if a and b were both 0, that means that you would have 0 x's and 0 y's, and then you would just have 0. So that's important to know. And then a solution of a linear inequality is an ordered pair that makes an inequality true. I hope you know that that's what solutions are. Solutions are values that make statements true. So, number 5 says, graph each ordered pair on the graph above, so that's the one on the left on mine. Determine if it will allow Axel and Anisa to remain within their plan and explain your answers. So 250 would be about, it's a little bit hard to tell on this teeny thing here, but roughly about here. And yes, that would work. It is in the solution area below 250. It's in the shaded area. 150 would be roughly here, and that would not be in the solution area, so it is outside the values that make the equation true or the inequality true. So all of that shaded region is a picture of all of the values, all of the coordinate pairs that make that inequality we wrote a little while ago. This one, x plus y is less than or equal to 250. Everything in this blue area here makes that true. So, wow, did you see how that line went right on that? That was amazing. Anyway, 225 and 25, let's see, that would be about, oh man, that's teeny tiny. 210, 20, 30, so it's going to be here. Yeah, I think that's right on the line. Well, let's see if they add up. 225 plus 25 would be 250. It is right on the line, yes. On the line that is included in the solution. So it does make the inequality true, so we're okay. And then 20 and 120 would be about, right about here, maybe, ballpark. And yes, that works. The explanation is going to be the same every time. That still makes the inequality true. And then 120 and 200, 120 and 200, 180, 190, 200 would be about here. I'm only getting close there. And that is a no. That would add up to 320. And that's too high. So, a little summary here. The graph of Axel and Anisa's storage plan above is an example of a graph of a linear inequality. So there's a line and a half plane that's shaded. The half, or well, it's a half. It doesn't look like an equal half, but that plane goes on forever. So it's one side of the plane that, and all the points in the shaded region are the solutions of the linear equality, the ones that make it true. Everything I have talked about on this page, you might need to spend a little more time thinking about, even writing about or asking about, to make sure you really own it. What a graph is a picture of solutions, and what solutions are values that make a mathematical statement true. So that was one big page of a lot of important stuff. And bring your questions to class and we'll pick it up there.